This next lesson is on the properties of logarithms. Our goals are to use the properties of logarithms to expand a logarithmic expression, use the properties to write a logarithmic expression as a single logarithm, and evaluate logarithms with bases other than e or 10 using a calculator. Did you know that the properties of logarithms follow the properties of exponents? Let's take a look. Here are the rules. Rule number 1. Log base b of m times n equals log base b of m plus log base b of n. This is similar to multiplying terms that have exponents using a like base. The second rule, log base b of m divided by n equals log base b of m minus log base b of n. Similarly to dividing variables with exponents. Next, log base b of m raised to the k equals k times log base b of m. Now let's try some examples. Let's expand log of x times y cubed. So first, we're going to use our rule 1. This allows us to deal with the multiplication inside the logarithm. So we'll be left with log of x plus log of y cubed. Next, we can use rule 3 to work with the exponent. And we'll be left with log of x plus 3 log of y. Let's try another one. This one, you see we have a fraction inside of our logarithm, so we're going to use rule 2 first. This is our quotient rule. We'll have natural log of x squared, the cube root of q, which is our numerator, minus the natural log of y square root of t, which is our denominator. Next, we're going to use rule 1, which is our product rule. So we'll have ln of x squared plus the natural log of the cube root of q minus the natural log of y plus the natural log of the square root of t. Now we can simplify and rewrite our exponents. So we'll have the natural log of x squared plus the natural log of q to the 1/3 power minus, distributing our negative, the natural log of y minus the natural log of t to the 1/2 power. Now we can use rule 3. This is our exponent rule. We can bring our exponents down in front with the 2 natural log of x plus 1/3 natural log of q minus natural log of y minus 1/2 natural log of t. And this is our final answer. So now that we've expanded 2 logarithms, let's try some examples condensing logarithms. We're going to use our same rules. So to start, we see we have subtraction and addition as well as coefficients. So we're going to start with the coefficients to make them exponents. So we'll start with rule 3. So we'll be left with natural log of x cubed, bring this up, minus the natural log of the square root of y plus the natural log of z to the 5th. Now we can use rule 2. This is our quotient rule since we have this subtraction here. So we'll be left with the natural log of x cubed all over square root of y. Remember, to combine them, the terms that you're taking the natural log of will be divided. And we also have our natural log of z to the 5th being added. So now we can use the product rule, which is rule 1. we'll be left with natural log of this part times z to the fifth. So we'll have x cubed z to the fifth all over the square root of y. And that is our final answer. Let's try another one, condensing logarithms. This one might be a little trickier. So first we're going to use rule 3 like we did before to rewrite this to have exponents. Rule 3 gives us ln of x cubed minus the quantity of ln square root of y plus the ln of z to the fifth. Now we can use rule 1 to combine what's inside our parentheses. Rule 1 is our product rule, so we'll have natural log of x cubed minus the natural log of the square root of y times z to the fifth. Now we can use our rule 2, which is our quotient rule, because we have a natural log subtracted from another natural log. This gives us the natural log of x cubed all over the square root of y times z to the fifth. And this is our final answer here. Let's try one more condensing. Here we have 4/3 log base b of 27 minus 2 log base b of 9. So again, let's start with rule 3 to move our exponents, our coefficients to exponents. So our 4/3 becomes the cube root of 27 raised to the 4th power. So we have log base b of the cube root of 27 to the 4th minus log base b of 9 squared. So now we can simplify this and our 9 squared, and we'll have log base b of 3 to the 4th minus log base b of 81, because the cube root of 27 is 3. Now we'll raise 3 to the 4th power, and we'll have log base b of 81 minus log base b of 81, and we'll get 0. Now, what if I want to use my calculator to value logarithms? You can only use this when you have a base of 10 or e. So we have this nifty formula called the change of base formula. It says that log base b of a can be rewritten as log of a over log of b, or natural log of a over the natural log of b. So let's try some. Let's evaluate log base 7 of 5 using our calculator. To do this, we're going to have to use the change of base formula. So we have log base b of a, and we know that's going to equal log of a over log of b. So we'll end up with the log of 5 over the log of 7. And this we can put into our calculator. It's the log of 5 divided by the log of 7. And we get 0.827. We can see this works also if we use the natural log. We can use the natural log of 5 divided by the natural log of 7, and we're going to get the same answer. Let's try a different one. We have log base 0.4 of 8. So this becomes log of 8, which is our a, over log of 0.4. And we can plug this into our calculator. Log of 8 divided by log of 0.4. And we're going to get negative 2.269. We can see this also works for the natural log. Natural log of 8 divided by the natural log of 0.4. We still get negative 2.269. And that is it. So it's important to remember our 3 rules of logarithms. Our product rule, our quotient rule, and our power rule. And that is it for this lesson.